So in this video, this video will be the a redo for the data center. There was an error on the previous video, so I want to make some corrections. So as we look at your data center and the power distribution of a data center, we will start with what you call utilities, right? So your utilities are here, okay? And from your utilities, this powers the electricity from the utility goes straight in to what you call the ATS. And the ATS stands for automatic transfer switch. Okay. The automatic transfer switch then allows the electricity to go to what you call the UPS. Okay, the UPS. And the UPS stands for uninterrupted power supply. And that is really your battery. Okay? That is your battery. From the battery, it goes straight, and we're gonna let's do it in a way where it's easier to read instead of a diagonal line. We'll go straight down to your rack, just like that. Okay, your rack is basically your servers. Okay, that's actually where all the data is held. Okay. So this is the principal line here, right? So let's label this. Let's kind of go over this in detail a little bit, okay? So the utilities can range, right? So utilities start at the data center at 34.5 kV, which is kilovolts, which is 34,500 volts. There's a voltage drop to 480 volts. This voltage is AC. This voltage here is AC. Okay? That's number one. Now, obviously, there is a transformer here. So if you would have a transformer and another transformer, obviously there's an end-to-end ratio we covered in mutual inductance that creates the AC drop. The 480 volts here AC, okay, has to convert before it goes to the UPS. It has to convert to 480 volts DC. Then it goes to your UPS. So let me kind of erase this and do this again, so that it's kind of a clear understanding. Okay. .480 volts AC goes to 480 volts DC. Why is this important? Because battery is always charged in DC. Okay, battery cannot be charged in AC. If you stuck a 9-volt battery or rechargeable battery inside a plug, you will make the battery explode, probably catch your house on fire. That's not a good idea. AC goes to DC, then it always charges the battery based on DC. Okay, now the battery always discharges DC. So it goes from 480 AC, 480 volts DC, 480 volts DC. When the battery discharges, now it's charging the battery, now it discharges the battery, then it goes to 480 volts AC. Then to the rack, it becomes 208 volts AC. Okay, and this right here is another transformer. So here you have a transformer drop here, AC transformer drop here, you have the AC transformer drop here. This concept from 480 AC, 480 DC, then 480 volts DC, 480 volts AC is called double conversion. So we'll write double conversion. And that is your 480 volts AC to DC, and I'll just put it here because it's all the same voltage, DC to UPS to DC to AC. Okay? This is so that the voltage is smooth, because you really want, because you have sensitive data and you do not want fluctuation in the current. Any fluctuation in voltage and current is going to affect your data, and you may lose data, you may damage the machines, right? And you know, everything is on servers, bank accounts and everything's on servers. So you have to have it there. Okay, that's number one. All right, so that's a principal line. But there is something else. So let's just say your utility goes out. What happens then? Well, your utility, your generator is called, we're going to call it a G, generator, right? And we're going to write generator. Your generator supplies at 480 volts AC. And it simply is going to supply here. Okay. So the generator is now supplying 400 volts AC. It comes in at 480 volts here. It transfers to DC. Back again, same thing, right? So you really don't need a transformer drop here because it's already generating 400 volts AC. Okay. Now, the key to this is that the generator is only on. So the generator is only on when? The generator is only on when the utility is out, but it takes 45 seconds at the fastest for the ATS switch to transfer from the utilities to the generator. If that's the case, right? So what's going to happen? So if the generator takes 45 seconds, right? Seconds to turn on, then your UPS must be on a straight DC. So UPS now must supply. Right? UPS must be on for 45 seconds before the generator turns on. And the UPS cannot be on for a very long period of time. Okay? This concept here is called maintenance bypass. Okay? So the first thing, so if we have routes, let's call this route 1, route 2, 3. Okay? Let's call this 4, and let's call this 5. Okay. So we want to call it our routes, our path, whatever you want to call it. Our primary route is what? 1 to 2 to 3. This is simply called online. When you're fully online, utility is on, is at the ATS, and the battery supplies to the rack. Now, the secondary route, when the utility is off, okay, is from 4 to 2 to 3. 4 to 2 to 3. Okay? Now, what happens if the power goes out and the generator is on, and then the generator is something's wrong with the generator or the battery? We have a problem. So every 15 to 20 days, right? Every 15 to 20 days, you have to check if the generator is working, the battery's working, if everything's working properly. Now, obviously, there's backup generators and backup UPSs, right? There's complex systems, but we have to check it's working. So this route here, which is your secondary route, right? It's called maintenance bypass. Okay? And for every 15 to 30 days in this maintenance bypass, okay, we undergo what we call server maintenance. Now, when you know what's happening in server maintenance, they're doing a maintenance bypass, turning on a generator, and making sure everything is operating properly. Okay? Now, the third route, which is probably your, we call secondary route, let's just call this, tertiary. Okay, let's call this a tertiary route. And this tertiary route is 1 to 5. 1 straight to 5. That's the last thing in the world you want, because the terminology is not correct. So the layman's term, I would say the industry term is called dirty power, but that's not the proper language you want to use. In your interview, you want to say brownouts because AC fluctuates. Okay, this is not good. Okay, so in this scenario, we understand the pathway. The initial pathway is here. The secondary pathway is here, and that is your server maintenance. And the third, this is the last one you want. This tertiary pathway, 1 to 5, is called static bypass. Okay? So know your online bypass, know your maintenance bypass and what happens, understand it's a server maintenance, understand the static bypass, be able to do this whole thing. Okay? Now, in a regular scenario, anyway, from 480, obviously it has to come down to 208 volts. I mean, it's got no choice, right? So from 480 volts here on the static bypass, this has to be 208 volts AC. Okay, and this obviously another set of inductors here, right? So it's straightforward. So know this stuff, study it, okay?